Today we will be discussing an agent-based model that investigates resource extraction, labor conditions in the global south, and implications of the industry emission in the global north for climate change. This model has been developed for, simulating evolutionary political economic policies aimed at addressing these issues. This model features heterogeneous agents interacting within an ecosystem that contains two distinct regions, an abstract global south and global north, with interconnected, sectors for consumption goods, capital goods, and resource production. So, before we discuss the details, could you please introduce yourself?
Yes, hello. My name is Lena Gerdes. I did a PhD at the University of Economics and Business in Vienna. And the PhD is in social ecological economics. And I've been working on this model in part or in the context of the PhD.
To start, can you explain the main objective of this model? And how does it help address the interconnected issues of resource extraction, labor conditions, and climate change?
Yeah, thank you. We mainly developed this model in order to study the unequal exchange relations. So often it is claimed that international trade or global trade is profitable for all parties involved in the trade. However, there are often social and ecological consequences happening at some places where involved in the trade. So especially if we talk about resource extraction at the places where the resources are extracted, the local residents face social problems and ecological problems. And these aspects are often neglected when we talk about international trade and who profits from it. Therefore, with this model, we wanted to have a look at at these implications. We wanted to show them with the model, and also develop policy suggestions or develop some ideas on how we could mitigate these challenges.
What were the main challenges you faced while developing this model, especially, when dealing with complex elements such as simulating heterogeneous agents across two distinct regions, or incorporating the interactions between resource production in the global south and industrial emission in the global north?
Yeah. So one of the main and biggest challenges was stabilizing the economic systems because we have in both regions, so we feature two regions, as you said before, and both regions have a local labor market where the heterogeneous agents are working. They are part of it, and we have a consumption good market, we have an intermediary good market, and we have the resource production. And stabilizing this complex interaction along the value chain, including the agents which are working at these at the production places, and also have to consume the final goods. Getting this to work was one of the biggest challenges, especially dealing with shortages in this regard. So once, for example, especially at the top of the production chain, if there was a problem with the resources, the next sector wasn't able to produce, which meant also a shortage for machineries in all the other sectors, which resulted in less goods, less final goods, but also less resources again. So we had some downward spirals, and it was quite difficult to actually stabilize the economic interactions in a way that we had a functioning economy over a long enough time frame of several decades, so we had enough time to actually analyze what was happening in the model. Also finding out how we create the interaction between the global north and the global south, and so of these two distinct economic regions working on their own, but also creating the interconnection that still both regions would function on their own, but also with the trade. That was one of the biggest challenges.
Now let's talk about the findings. What are the key insights gained from running simulation experiments, particularly regarding the interaction between resource extraction and labor conditions and, I mean, emissions? Have any patterns emerged about how different political economic policies influence these outcomes?
So we could clearly see that the more production we had, of course, in the global north, the more problems we were facing on a global level regarding global emissions, but also on a local level in the global south regarding the extraction of resources. So the local pollution was increasing a lot. And we found that institutions play quite a crucial role there. So we need global institutions which are able to actually enforce sanctions for different kinds. So in the global north, we implemented sanctions regarding the especially CO2 emissions in the producing sectors, and we implemented sanctions for the mines which were destroying the local environment basically. And we could see that in order to protect the labor and the environment, we needed both. We needed the sanction mechanism as well as the subsidies mechanism, helping to support the change to a more sustainable economic system. So just policies without subsidies were not so effective, which is in the end not a wonder, because you always need money in order to invest into innovation policies. That was one of the main findings. And what we didn't have in the model, but what we could generally, where we didn't invent a solution to, but it was clear that if the consumption would stay the same, the pollution and the emissions were rising. So we had to deal in the policies that we studied, we had to deal with mechanisms in order to reduce the emissions during the production processes. But we could also see that it is quite difficult if we don't have mechanisms to actually reduce the final goods or the goods produced.
You have made this model available through comsys.net. Could you talk about the, challenges involved in sharing this model, and how did you ensure it was well documented and, usable by other researchers?
Yeah, so one of the main challenges in publishing the code on ComSys was cleaning the code, making it readable for other people. So especially removing deactivated code parts, which we had used during the production process or during the coding process, but which we didn't need in the end. Creating a readable order and including comments in the code, and also especially changing illogical or incomprehensive names of variables, which we created throughout the programming process. And of course, we knew what we meant by it, but for others to reproduce and to understand the code, we had to deal quite a lot with that. And there was also a learning process to understand a bit better on how we can code in order to ensure its readability. And in the end, it was also quite a challenge trying to explain everything in the ODD in a way that a reader which didn't work with the code for years was able to understand the thought processes, but also understand exactly what was happening in the code, so including all the equations of such a complex model, because we had a lot of different interactions, and putting them into proper mathematical equations was a whole process on its own. And in the end, of course, just making it look relatively ordered and neat for just the interface. That wasn't too much of a challenge.
My last question, what's next for this model? Are there any planned updates or follow-up studies, to explore the implications of new political economic policies or further investigates the regional dynamics between the global south and north?
Yeah, we are currently working on an extension related to energy and loosely related to the European Green Deal, because the model does not feature energy, which of course is quite a shortcoming because every production needs energy. But it adds quite a next layer of complexity, this energy extension. And so we are currently looking into the implications an energy transition would have. Not saying that it's bad to have this energy transition. It's really important. However, at the same time, we need to be aware that it has new challenges, especially on a global level, which we have to be aware of. And this we want to study with a model. So we are currently working on, first of all, implementing energy in the production system, so in the value chains, which adds a whole new layer of complexity, because adding a different part to the production functions changes, of course, the whole model. So we have to rethink the whole production mechanisms. And after that is working, we will work more on the implications and also on mitigation strategies and policy ideas on how to actually deal with also negative consequences of a green transition.
Thank you for your discussion on this model.
You're very welcome.